can make this a little tiny bit bolder. Ladies, come on. All right, so these we're finding between 0 and 2 pi, all of these. And again, a nice way to start, if you like, is to start with all solutions and then work your way. If you're only going to 0 to 2 pi, absolutely give me 0 to 2 pi. So we took this guy, we isolated your cosecant, there's your variable. Important when you take the square root, you get a plus or minus. Now, if you'd rather not look at a cosecant and you'd rather look at its reciprocal, then don't forget to flip this side over. That might be recognizable to you. 1 over radical 2, there's your 45-degree angle. So 45 degrees is what you need to know. So you were only 0 to 2 pi, so therefore you could say 45 goes into 180 4 times. This is your 4 pi over 4. So you give me 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. If you gave me the all solutions, this one and exactly 180 across from it, then this one and exactly 180 across from that one. But since you only had to go from 0 to 2 pi, probably was just easier just to get them all the way around. You tell me what you don't understand. Because I see partial answers on some of yours. I see work to get there, but then no angles. Okay? This guy, you could do the difference of perfect squares, tangent plus 1, tangent minus 1. You can pull the 1 to both sides and take the square root. So again, pretty much looking at the same angle. Who has a tangent of 1? A 45-degree angle has a tangent of 1. In all 4 quadrants again. So it had the same answer as the last one. So n pi, if you do this guy, then plus n pi. If you do this one, then plus n pi. If you just had it, you can just run them all the way through. If you're too quiet, it's going to make me nervous. Okay. This is hard to recognize. If cosine is my variable, I'm looking at this. How the heck do I solve that? X cubed equals x. I cannot divide by x, so I have to factor. So I have to pull everything to one side. That's why we pull the cosine to one side. Then we factor out an x or we factor out a cosine. Then you're left with your perfect squares. You can factor into perfect squares. You could add 1 to the other side and take the square root. Whatever you get. You've got 3 situations now to look up. And because they're zeros and ones, they're your quadrant angles. So again, look at your quadrant angles. Your quadrants are x values. You almost have all of them here. You do have all of them. 2 in one and 2 in the other. So where is it? Negative 1? Right, here's the positive 1. Here's the negative 1. Where is it? 0? Here and here. So you have all 4 quadrants you can do with this. Good? And it kind of makes sense. If you're cubing a 0, it's still going to be 0. If you're cubing a 1, it's still going to be 1. If you're cubing a negative 1, it's still going to be negative 1. It kind of makes sense. Excuse me. Okay.
Pi over 2?
Yes. I'm at the 0, pi over 2, pi, 3 pi over 2. And be careful how we ask this. It said between 0 and 2 pi with the soft bracket. So you have to give me the 0, but I don't want the 2 pi. We were just talking this morning. I think allergy season is amongst us already. Okay, this guy's got a lot going on here. There's numbers everywhere, and there's a sine, and there's a cosine. So in one equation, I have 2 variables. There's nothing I can do with the cosine. That's the basic one. I can only break things down to cosines and sines. But the sine squared, there's one identity, just this one, that you have to memorize. This is Pythagorean's identity. This is the x squared plus y squared equals 1. Solve it for sine squared and replace it. Substitute this out with the cosine word. Now, be careful. I moved everything to one side of the equal sign. You didn't have to move it yet. I just moved it already. I took the opposite. I took the opposite. You're going to distribute your 2, and I moved everything here. Now be careful. When I collect the 2 minus 2 from the same side of the equal sign, if you left yours on the other side, it probably just canceled out fine. This guy has a negative. I have to bring it down. My 2's are canceling out. You always want your leading coefficient to be positive. Granted, you can factor out a negative, but you want your leading coefficient to be positive. So since it's an equation, divide or multiply by a negative 1. And now both of these contain a cosine. Factor it out. So remember, we're all solutions. We're completely the opposite of our inverses. All solution says, tell me wherever cosine is 0, oh, that's a quadrant, we're x. So here is a 0, here is a 0. So this guy satisfies my pi over 2 and my 3 pi over 2. This guy says, where is cosine negative? Cosine uses the x values. Cosine is negative 2 and 3. Yes, 2 and 3, where x is negative. So I set this up, 1 over 2. I recognize my special triangle. That's a 60. So I've got a 2 pi over 3, and I have a 4 pi over 3. And if you did it the other way, you would have to do plus 2n pi, because it's not opposite each other. And you would have to do 4 pi over 3 plus 2n pi for all solutions. But since I only asked you between 0 and 2 pi, that was fine. How are we doing with these? Yes, no?
It's just the angle part is confusing sometimes.
Once you get to that part, you only did the algebra part. Now you got to do the trig part. The trig part is completely the opposite of inverses. It said, show me where in your 4 quadrants is cosine negative. Show me where is cosine 0. What I always find confuses kids is the 0s and the 1s. Because cosine uses 0s and the 1s at the quadrants. Tangent uses a 0 at a quadrant, but the 1 is 45. So you really have to kind of think about it. You could even use your calculator just to start it. Like say I was really confused. I don't even know where cosine is 0. So I'm going to pull up my calculator and I'm going to just put my calculator in degrees, because someone's going to have to just tell me where should I look. So I say second cosine 0, and it says 90 degrees. So now I know it's a quadrant. So now, Alasia, I say, well, if it's 90 degrees, I look across. Is this also a 0? Yeah. My zeros, I'm going to find 2 of them. My 1s and negative 1s, I'm only going to find 1 of them, because while this guy's a 1, while this guy's a 1, this guy's a negative 1. But my 0 is going to find 2 of them. Now, when we did your restriction angles, we always only found 1, the one that your calculator gave you. But now you're going to look for all of them. And if I have trouble with this, where is cosine negative 1/2? I could even, if I want to, put that in. Say, tell me where it's negative 1/2. I really don't know where to start. So now, oh, it's 120? Oh, okay. I know I'm in the second quadrant. Oh, yeah, if that's where my x is negative, I have another one down here. So it'll kind of like help direct you. You know what I'm saying? It'll help direct you. It does the true inverses, and we want all, but it'll at least give you like a starting point. And then you could say, well, if my cosine is negative here, and it uses the x, shouldn't I also be negative there? Same triangle, right? Okay. we have a nice trinomial, x squared minus x minus 2. Pull the secant out for the meantime and factor it. So you factor into x plus 1, x minus 2. Make sure your factors are correct before you go and do the rest. Make sure when you multiply those last two things that that comes out the same way and that your middle terms are the one that you want. If I want the negative, I have to multiply the higher number with the negative. So make sure that works out before you even go to this part. Then set each one. Now, remember this is the reciprocal of cosine. A secant can be 2 because the secant's range is from 1 to infinity and from negative infinity to negative 1. So it uses the opposite of your cosine. So again, I could find my pieces. If I'm confused, I can put this in my calculator. This is going to point me to 180 degrees. When I'm here, is this guy also a negative? No, that guy's a positive. So that's the only one I want for this. Where is my cosine 1/2? It points me here with the 60-degree angle, and I say, oh yeah, there's x is positive. I have another one. So if you struggle, look for it in your calculator. That'll help give you placement. If you were missing part of this, is it clicking? Somewhat? I went here. Yes. Okay, this one? This is a very weird one. I got two different things in here. I've got a secant, and I have a cosecant. So I'm just going to make this be x and this be y. So I've got xy equals 2y. Well, I know I can't divide by a variable. The only thing I could do is factor it out if it's in common. I can't divide by it because I lost my answer. So I pull this to one side. Now what do they have in common? A y. So now do I get two factors that I could separate with two different variables? So that's exactly what I'm going to do here. I'm going to move my cosecant over. I notice they have a cosecant. So now I've got two factors that use different functions, and I'm okay with that. I set this, and this looks very familiar to me. I change it to the sign, but when I flip this over, can I divide by 0? So therefore, this one has no solution. This one has no solution. Could I ever get a cosecant of 0 if you think about it? Here's my sine curve. Let's think about your sine curve. Your cosecant curve goes over here, right? Will it ever touch the 0? Will y ever be 0 for a cosecant? No. What's the range for cosecant? 1 to infinity or negative infinity to negative 1. I'll never get a 0. That's my sine and cosine are in there. So right away, if I visualize this curve, I like to visualize the curve rather than the triangles. If I visualize the curve, I'll never get a 0 here because it goes to the 1s and the negative 1s. Then I'm exactly the way I was just the problem before this. Cosine is positive in 1 and 4. Cosine uses x's. Use the fact that your x-axis is positive between 1 and 4. And that'll give you your two triangles that you need. Okay, now this one probably was a little tougher. I got two different things here. But I only know one of these. And it's not going to help me here because neither one of them are square. But I do notice that sine and cosecant are reciprocals of each other, right? So if I can't replace sine, that's the lowest it can go. But I can replace cosecant with 1 over sine. And it doesn't look pretty, but if I multiply by a common denominator, I get rid of my fraction. These are still algebraic equations. Still equations. So I say, okay, multiply by sign, I get a sine squared. Multiply by sign, that comes out, I get a +1. Multiply everything by 0, I'm a 0. This is not a perfect square. Doesn't have a minus in between. Not perfect squares. I'm kind of stuck. So I move the 1 over, divide by 2, and then I take the square root. Now, when you take the square root of a negative number, can we take a square root in our real number system? No solution. I stopped right there. I did all that work trying to figure out how to get at this, and I had no solution. Okay. You're awfully quiet in here. This is the last one. Now this one was a tricky one. So, no one told me what to do with secant and tangent squared, but I do know that I had to memorize this one identity. And if I want the word tangent from this, what would I have to divide everybody by to get a tangent out of this? Cosine. So since it's squared, if I did this, doesn't this give me tangent squared? So since it's an equation, I have to divide everybody by this. This is your other identity, but you don't have to memorize it. You can find it. This cancels out to 1, plus there's my tangent squared, and 1 over cosine is a secant, and this is a secant squared. So now, I'm looking good. I could replace secant squared with 1 plus tangent squared. And now everybody will have the same variable. So I replace this guy, I distribute, I collect my like terms. Be careful of this. You're on the same side of the equal sign. I've got 2 tangent squared and 1 tangent squared. I have 3 tangent squared. I have a 2 minus 3, I have a negative 1. And again, we can't factor, this is not perfect squares, so I add it to one side, and I recognize the radical 3 and the 1, right? There's my special triangle. Like I was telling you guys yesterday, there's not a lot of factoring that we can do, because what are the sides of your special triangles? 1, 2, radical 3, radical 2. So they've got to be small, and the quadrant angles are 0s and 1s. So we're not doing like major factoring. So again, just be careful, you get a plus or minus, y over x, that'll help you find your quadrant angle, and you just have to give me all 4. Okay, so talk to me. Tell me what troubles you. Did this help? Make it worse? All right. Oops. Now, if this troubles you, set it like this first. Now, you have to factor these guys. However, remember, our numbers are not large. There's only one set of factors for 2. It's a prime number. And only one factor for 1. So there's not a lot to do with this. And both of my signs are going to have to be positive. So if you started it like this, both signs are positive, you can't miss. No tries. The first try we do it, we get it. So here's my factors. 2 cosine x plus 1. I'm going to put the cosine back in there. And cosine x plus 1. Make sure before you do this that you make sure that it works. Multiply this last one, because that's usually the one kids miss, and this will give you a 2 cosine. This will give you a 1 cosine. There's your 3 cosine, your middle. Just eyeball it and make sure your factors work. So now, God bless you. Factors set to 0.
Wait, so where did 3 come?
3 is your middle term. This gives you 1 cosine. This gives you 2 cosine. So your middle term adds up to 3 cosine. Okay? It's when you multiply these, see this little smile here? That gives you your middle terms. Gives you your middle terms. I could say rainbow. I've been watching too much Disney with my grandson. I could say it goes follows the rainbow. Okay, so now, solve for cosine. Subtract 1, divide by 2. So subtract 1 for this guy. Now, we did the algebras. It's amazing all those songs and all those things I'm thinking back to. My kids are a lot older. So, it's like,
I
whoa.
know pretty much every theme song.
Oh, you do?
I still watch Disney Channel.
Ah.
She always wants to like the Donkey Stuffing song.
Oh, yes.
I just love Donkey Stuffing.
They have such cute little beats to them. Okay, so we've got 2 things to do. We have to find whatever angles in all solutions that have a cosine of -1/2. Now, let me just kind of trace this cosine curve for a second. So -1/2 is somewhere like here. Don't I have quite a lot of solutions that if I keep on going, that have all of these for -1/2? So I say to myself, what quadrants am I in when cosine is negative? 2 and 3, because cosine is the x-axis. So where is my x-axis negative? That's all you have to think about. Cosine is x, cosine before sine, x before y. Now, cosine is x over r. 1 over 2. Oh, there's my special triangle. What reference angle is this? 60. Good. How many times does 60 go into 180? 3. So this guy's going to be 3 pi over 3. So what is 1 short of 3 pi over 3? 2 pi over 3. And what is 1 after 3 pi over 3? 4 pi over 3. So from 0 to 2 pi, this is a 3. I just missed the thing, so my arrow came up. That's a 3. Sorry. From 0 to 2 pi, I have 2 angles. From 0 to 4 pi, how many angles would I have? 4. So if I want to write all solutions, I can come here and come around another 2 pi. So these are going to be plus 2n pi. They're not opposite each other, where n is any integer. Now, I'm going to add this one out the long way. So we have to go from 0 to 4 pi. What denominator am I using for these guys? What's these denominators?
Oh,
3. So let's convert this to thirds. So how would I convert my numerator? Multiply by 3, 12 pi over 3. So when I hit 12 pi over 3, I have to stop. So I start with these guys. Here's my first one. 2 pi over 3 plus 2n pi. 4 pi over 3 plus 2n pi. Now, every time I do this, didn't we say we had to add 2 pi, add 2 pi, add 2 pi? Yeah. Well, I can't add 2 pi when I have a fraction. So I take this guy and I convert 2 pi to thirds. So how many pi's would I have now? 6. 1 times 3 is 3. 2 times 3 is 6. Every time around, I'm going to add 6 to my numerator because aren't my denominators the same? So I start with 2 pi over 3, and I add 6 to my numerator. What do I get? My common denominators are good. So 8 pi over 3. If I added another 6, what would I be? 14. Whoops, 12 is my limit. So stop right there. So now I go to my 4 pi over 3. And didn't we say with 4 pi over 3 we also had to add 2 pi? So let's go to the same denominator. because I can only add fractions with common denominators. And isn't 6 pi over 3 the same as 2 pi? Right? So if I add 6 to the numerator, what do I get? 10 pi over 3. If I add 6 again, what do I get? 16. Whoops, I'm past my 12. So here are my 4 angles. So from 0 to 2 pi, I have 2 angles. And you just told me from 0 to 4 pi, I should have 4 angles. And that's that. Now, yesterday we took a little shortcut. Since we were only going to 2 pi, and then we did only the 4 pi, we said, keep this pattern going. If this was 3, this is 6, this is 9 pi. Which one short of 9 pi? 8 pi over 3. Which one after 9 pi over 3? 10 pi over 3. Could I do it that way too, since I'm only going one more time around? Yep. But I decided to do that just in case you have other ones where you have to add and subtract. They're all factorable. All of them are factorable. You don't have to use the quadratic equation. This one. Where's cosine negative 1? So I notice cosine of negative 1, it must be at a quadrant. So cosine is the x value. And even if I'm not sure, I can put this in my calculator. What angle is cosine negative 1? And it's going to come back and say 180. And I'm going to say, oh, this guy is a positive 1, so I only have one angle, pi. So for all solutions, if you're doing all solutions, I have to come back and add 2 pi plus 2n pi. So that's part of my all solutions. If I'm from 0 to 4 pi, if this is 1 pi, this is 2 pi, what is this? 3 pi. So I also have pi and 3 pi. Thanks, Connor. Okay, we got so caught up in that one, we forgot to go back.